Alright, so today we're going to cover two sections, 7.3 and 7.4. It's over special products of polynomials and then solving polynomial equations in factored form. So, kind of building on what we did in 7.2 where we multiplied polynomials. Okay, so that's what we're going to build on in this section. So first thing we need to talk about is what's called square of a binomial. Square of a binomial will look like this. This will be all they give you, and they tell you to solve it or to simplify it. The main thing to understand is, here's the biggest mistake I see kids make whenever they are working on squares of polynomials. They immediately think, when they look at that, that equals a squared plus b squared. Because they think they can just distribute that 2 through. Okay, you cannot do that. You got to remember what an exponent of 2 stands for. An exponent of 2 stands for multiplying the base, which our base here is a plus b, by itself. So that's why a plus b squared equals a plus b times a plus b. And then you're able to FOIL or use distributive property to simplify that. So make sure you do not make that mistake. Once you get to here, it's very straightforward and you know how to FOIL. But it's making sure you do not get confused and do not rush through it to think that that 2 can be distributed through. And same with a minus b squared. It's just a minus b times a minus b. So let's look at a couple examples of this. So, part A, it says find the product of 3x plus 4 squared. So again, when you go to do this problem, a lot of students will immediately be like, okay, well, I'm going to distribute that 2 through, distribute the 4, and that's what I do. That is not the correct process here. You have to take this base and multiply it by itself. So that becomes 3x plus 4 times 3x plus 4. So once you write it like this, we can go ahead and use distributive property, or FOIL, either one, to solve this problem. So, for FOIL, I do first terms first. So 3x times 3x, that is 9x squared. Again, remember, if you have x times x, you add the exponents of 1 to become 2. Then we go, outer, 3x times 4. That becomes 12x. Inner, 4 times 3x is 12x again. And then last, 4 times 4 is 16. And then we need to combine like terms. We bring down 9x squared. 12x and 12x combine to be 24x because we just add the coefficients. Leave the x as it is, and then bring down my plus 16. So this is what your final answer should be. Like I said, a lot of the times I will see students distribute that through and get 9x squared plus 16 as their final answer. Okay, that would not be correct because we also have the plus 24x. So be careful whenever you're doing these types of problems. Okay, so I want you to try the second one. Pause the video, try 5x minus 2y all to the second power. Okay, hopefully you've tried that. Again, you need to split this up into 2 binomials because that's what that power of 2 represents, that you have 2 binomials being multiplied here. 5x minus 2y and 5x minus 2y. That is what we're working with here. Okay, so when I FOIL, we do 5x times 5x first. That is 25x squared. Then we go outer, 5x times negative 2y. We multiply the coefficients, that's negative 10. And then x and y cannot be combined, so we just put them together as xy. Then we do inner, negative 2 times 5x is also negative 10xy. And then last, negative 2y times negative 2y would be positive 4y squared. Okay, so then I have to combine like terms, bring down 25x squared, combine negative 10xy and negative 10xy to become negative 20xy, and then we have plus 4y squared. So there's your final answer for this one. Okay, so make sure, like I said, that the math on that and the steps are not difficult. It's very similar, or it's the exact same thing actually as 7.2, where you FOIL. You just have to remember whenever you split this up that you cannot distribute that through. You have to split it up into two binomials. Okay, so we also have what's called sum of difference, and this is your sum of difference pattern. So if you have the same setup where you have the same term for the first and second one, but the first one is being added, the second one is being subtracted, this is the form. You don't really have to FOIL it because this is the same, it's going to have the same pattern every time, where the first term is squared and the last term is squared with a minus sign in between. Because if you actually FOIL, the middle terms would cancel each other, and that's why it turns out to be like this. So like for example, x plus 3, let me show you what I mean by that. X plus 3 and x minus 3, they follow that pattern because they're both x in the front, they're both 3 in the back, one has a plus, one has a minus. So what they did, they squared the first terms, x squared, they squared the last terms to get 9 with a minus sign in between. So like if I were to FOIL, let me show you what it would look like if I worked it out. FOIL f first, that's x squared. O outer, that's negative 3x. I inner, that's plus 3x. And L last, that's minus 9. So what happens is we bring down the x squared, but if we have a negative 3x and a positive 3x, those will cancel each other out. And then we still have the minus 9. So that is why it follows that pattern, because those middle terms cancel each other out. So as you can see, that's what that equals even if you FOIL. So that's like a shortcut if you have ones that are set up like that. All right, so for example, this first one, t plus 5 and t minus 5. The shortcut is we see that the first terms are the same, the last terms are the same with a plus and minus sign. So we can use that shortcut of squaring the first term, t squared, and then squaring the last term with a subtraction sign in between. 5 squared is 25. So there's your answer to that one. Okay, so you try B on your own. Hopefully you've tried it. Let's look at it. We have 3x plus y, 3x minus y. So again, we have that shortcut that we can use. So I'm going to square the first terms, which is 3x, and the whole thing squared would be 9, because we square the 3, and then we square the x, which would be x squared. So 9x squared is my first term squared, and then minus the last term squared would be y squared. So there will be your answer for that second one. So very simple if you have that pattern that you can run into. Very straightforward. So make sure you're looking for that as well. All right, so now that gets us into 7.4, which is over factored form. This says a polynomial is in factored form when it is written as a product of factors. So here's our standard form that we've discussed quite a bit. The factored form is basically what it is before you were to FOIL or before you were to multiply. Okay, it's factored out. So we're going to have to use factored form in this section to solve equations And we'll see how that looks as we go forward. But we're looking at factored form in this section. So this is explaining what we'll be doing. It says in this section, you will be asked to solve equations where the factored form of a polynomial is set equal to 0. To solve this, you set each factor equal to 0 and solve individually. So depending on how many factors there are, you're going to set each one individually equal to 0 and solve for the variable involved. So let's look at some examples. So the first one, we have 2x times x minus 4 equals 0. So again, this is factored form because this has not been distributed through yet. It's factored out. So whenever you have this, you have to set each individual factor or each individual term equal to 0 and solve. So here we have two terms. We have 2x, or two factors I should say. We have 2x and we have x minus 4. So each of those so that means we're going to have two different problems where we set this equal to 0 and that equal to 0 and we solve. So we'll have two answers on this. So the first one will look like this, 2x equals 0, because I can take that. And the next one will take that, and it'll be x minus 4 equals 0. And then you're just solving for x. So here, we divide by 2, and 0 divided by 2 is just 0. So our first solution is 0. And then we take this and solve for x. So to solve for x here, we add 4, cancel, cancel. X will equal 4. So our two answers on this, x equals 0 and x equals 4. Okay, very simple, pretty straightforward. That's what we're looking for in this section. So go ahead and try B on your own. Pause the video, see if you can do it. So if we attempted it, we have x minus 3 x minus 9 equals 0. So again, you're going to set each factor equal to 0 individually. So we have x minus 3 and x minus 9. So first equation will be x minus 3 equals 0. Next equation will be x minus 9 equals 0. And we solve individually. We add 3 here. Obviously the math on this is very simple. You just do 0 plus 3, that is 3. And then over here, opposite operation of minus 9 would be plus 9. So x will equal 9. So those are our two solutions for this equation. X equals 3 and x equals 9. So both of those would be answers that would work. Okay, so that's what we're looking at as far as factored form. You have to take each individual factor and set it equal to 0. Okay, so sometimes it says the polynomial will not be in factored form, so you must factor out the GCF or greatest common factor and then solve. Okay, so we'll look at what that is going to look like, but sometimes it's not going to automatically be in factored form for you. You're going to have to get it to factored form.